Hello. Before we do anything, can we just settle a little bet of mine? How many people are here just for the pizza and beer? Or primarily for the pizza and beer? Not that many. Okay. Hopefully the tech talk's interesting as well. So I guess firstly, who the hell is this bald guy on the stage? Why should I care? So I'm Adam. I'm Director of Technology at a company called Opia. I've been a software engineer for about 15-ish years, and I've been at Opia for about half of that. So I've been there for a long time. When I started at Opia, it was a team of 4 or 5 people, including Paul in the front. And since then, we've grown into a team of about 30 plus, a department with BAs, with data teams, with security stuff going on, with all sorts of stuff going on. So the kind of inspiration for this talk is, if I could go back 7 years, what would I have told myself to sort out quickly, and in order to have the team humming and not have all the issues and sort of slowdowns that you get, the politics of slow ways of working. So that's kind of the idea of this talk. What I'm going to talk you through is my top 10, distilled it down to a list of top 10, the things that everyone should be doing, and if you're not doing it all, a bit of a hint as to how you can get started, something tangible to run with. So, without further ado, the first one might be a controversial one, given this is a room full of tech people, is don't write the code that you don't have to. Shout out, does anyone know what this stands for? Yeah. What about this one? Okay, what about this one, which I did not make up? Yeah. Yeah, do the simplest thing that can possibly work. I swear I did not Google that. That's my favorite. It's definitely the best. These 3 acronyms, they're thrown around a bit, the first 2 are at least. They all essentially mean the same thing, which is don't waste time building things that you might never use. Well, I think we as engineers tend to fall into this habit of firstly working with product people and trying to design concepts up front. And sometimes you'll get given a solution and not really understand the problem you're trying to solve, and maybe spend 6 months building the solution. It turns out you probably could have built something in a month that would have solved 95% of the problem. So I think we all have a responsibility for that, and I think it's a good thing to instill in your teams to challenge requirements, challenge solutions. It's much more relevant for all of us in day-to-day writing code complexity. What tends to happen again is we like to overcomplicate things. We like to go and buy a book that's called Enterprise Patterns, Design Patterns, and go to work the next day and think, how can I use all these things and look really clever, and have a really clever big architecture. And often, I think actually that just tends to show your inexperience. And the best way to do it is to think, what is the simplest solution I can come up with to solve this problem? So my tip here really is, as engineers, try and make sure you understand the business problem you're trying to solve. Of course, I'm going to say that because I've got a director in my name. Focus on the business problems, try and solve that, and spend less time thinking about how to have a fancy, complex code solution. Tip number 2, design the code before you write it. Seems pretty self-explanatory. Like I say, I'm an engineer. I've been doing this for a long time. And I get that the fun part is generally when you've got music on, you're in a bit of a flow state and you're going well, your fingers are going like the clappers, and you're having fun writing some code, building some solutions. The problem, and the thing we want to avoid, is you get to the end of that development cycle and you step back and look at it, and either you've just broken the previous rule and you've written something really complex, you've written 10,000 lines of code, which is all really cool, but probably unnecessary, or you speak about it to somebody else and realize that actually it's the wrong solution. So there's lots of ways that you can approach this in a structured way. Normally they come with something driven development. At Opia we do a thing called API driven development. Most of the things we do have APIs, and so we have a rule. If you're going to introduce something which involves creating a new API, job number 1 is spec out the API. Use Open API, use Swagger, use something like that. Design what the API is going to be, get the team to agree at first, and only then you're allowed to start writing code. And by doing that, you make sure that you're not going to end up writing code that ultimately later on down the line you have to delete half of it because it's the wrong solution. Tip number 3, write code that's easy to change. There's not many quotes in here, but I like this one from Bob Martin. I don't know how many people are familiar with him. Good architecture allows major decisions to be deferred. And the way Uncle Bob describes this is really around the job of a software architect, which is really all of us, is not to make the decisions, it's to try and make a structure that allows you to make decisions later rather than now, and allows you to change those decisions later on as well. The reason for that, why would you want to do that, is because generally knowledge increases over time. We'll know more a month from now about the problem that we know about it today, the further you can push that issue down the line, the better a decision you'll ultimately have. The typical example that's always rolled out of this is things like databases. You start a new project, what database am I going to use? Is it going to be a relational database? Is it going to be a NoSQL database? Is it going to be a time series database or a key value store or whatever else? You could just make that decision on day one, or you could say, how do I design my code so that this is just not an important factor? I can change it down the line if I want to, or I just don't even have to decide it right now. I can build the rest of the code and just think about this later. In practice, this tends to be more domain-specific, things specific to your application. Not many people are changing their databases after the fact. But it could be anything. You know, if you're building a reporting system, do you know exactly how it all needs to be displayed to the users yet? And if not, is that something you can push off? And can you structure your code in a way that you don't have to make that decision today? So the tip here really is around that. Try and think about when you're designing code, how do you make it in a way that it's easy to change things later? And you know, in practice, that tends to mean decoupling things as much as you can. Have the UI code completely decoupled from the business logic, have different areas of business logic decoupled from each other as much as you can tends to help with this. Number 3, hopefully a reasonably straightforward one that we're all familiar with, write some tests, write some unit tests, write some automated tests. I will come back to this a little bit later, but absolutely, if you are not writing automated tests, start tomorrow. Don't forget the reason we write them. Sometimes people get caught in writing tests for test's sake. But really, the whole point of having tests is to reduce the number of defects in your code, make sure it's working the way that you expect it will. Improve the maintainability of the code, because generally code that is testable is also easier to read and easier to understand and easier to change. I, in my role, interview a lot of developers, and a lot of the time I hear things like, we just haven't got time to do it, we haven't got budget to do it, or we've done a little bit of it. And so I think there's a lot more people out there that just aren't doing testing or doing it a tiny bit than what most of us like to think. So my advice here is, if you haven't got any testing that's automated already, just start simple. Start with the most high-level basic test you can possibly do. Does one UI page of your application load? Can you automate a test to do that and build out from there? The next one, do code reviews. I've got a whole talk about this, which I think actually a couple of people in this room might have heard before. Let's do another audience poll. How many people here are involved in code reviews regularly via pull requests, ideally? Okay, and keep your hands up if you've ever been pissed off or angry as a result of that experience. Yeah. So that's a problem. So we all understand the value of code reviews. The value, it's similar to testing, you know, it's about improving the quality, reducing the defects, knowledge sharing. But generally, it's not a fun experience quite often. So I've got some rules. I've distilled it down to just these. Again, I could talk for half an hour on this. If you're a code author, review your own code first. Make sure the build is green. Make sure all your tests pass. If you do that, if you don't do those things, and a reviewer comes along, you're going to piss them off. So do that. Keep pull requests small. In my experience, no more than sort of 200, 300, 400 lines changed per pull request, I would say is about an optimal size, including tests. Don't go wild. If you create a 2,000 line pull request, all that's going to happen is either someone's going to skim through it and not really check it and just approve it, or it's just going to get ignored because everyone's too scared that it's too big and unwieldy. The next one, this is probably the most important thing I would leave you with in terms of code reviews, is if you're a reviewer, ask questions and don't make demands. Don't make statements like, this is wrong, do it that way. It's a horrible approach, and it's a really good way to get people's back up and make it seem like you are some authority, you know what you're talking about, you're more intelligent than that person. It's really easy how to make this a nice conversation and just turn that into a kind of question. Rather than saying, that's wrong, do it this way, say, is that wrong? Should it be done that way? It's a tiny change, and sometimes it might come across a little bit, getting the word, but it's that tiny change that just changes the tone of the conversation, and it means the person doesn't have to come from a defensive position. You don't come across as like an arrogant dick that just knows how it all should be. So really try and do that. Challenge yourselves to do that in every single time you comment on anyone's code. Always ask a question. It might feel a bit contrived at times, but just still pay off. Link to that. Talk about the code, not the coder. Don't fall into the trap of saying Paul's code over there, you know, Darren's function here, Tristan's whatever else. As soon as you start doing that, you start assigning owners and sort of maybe fault and blame over certain parts of the code. Talk about the code. There's a function there that doesn't need a name for whoever wrote it. That's irrelevant. It's the team's code. We're all responsible for it. Don't block over tedious issues. I'm sure we've all had people on the team before who only comment on pull requests and say things like that. You've spelt that code comment wrong. Don't care. It's not relevant. Sure, comment, sure, we'll fix it, but don't block the merge over that. And read the proposal, assuming one is written. For the Ricky Gervais with my beer on stage. Automate all the QA you can. So on the similar wavelength as before, all this stuff, try to just not even engage in it when you're talking about the quality of code or reviewing code. Especially things like code style. It's the easy one to pick on because it comes up time and again. I'm sure a lot of your businesses will, a lot of your teams will have some agreement on what the code style should be. My view on this is pick a style quickly, pick whichever one is the most common in your language or framework. Don't think about for ages trying to come up with your own or changing them. And once you've picked one, make sure it's one that you can automate. Every language out there has infinite number of linters and style checkers that can automate this stuff. And you want to get to the point, ideally, where you have automatic tools for checking these things so that your humans aren't doing it. And even get to the point of making a rule of if you can't automate in a linter, it shouldn't be a standard. So these things just don't come up and you don't end up with that brace should be there and just pointless discussion that's not adding any value to anyone's code. So code style is the easy one. You should really end up do as much of this as you can, depending on your language and how much you can get away with, as much sort of static analysis of the code as you can possibly get away with, to avoid people having to review that. Next, automate your deploys. I think there's quite a few cloud DevOps engineers in here, so hopefully this is fairly well agreed on. There are still a lot of people out there who have manual deployment process. Now, 10 years ago, that was someone logs via FTP onto a server and copies some files, or maybe does SSH onto a server and does some Git commands, and it's a bit of a mess. I'm sure a lot of you will remember that. These days, it tends to not be that as much, or that still goes on. But it could be things like someone has to go and log into AWS and clear the CloudFront cache, or someone logs into my specific application and does this specific process after it goes live, and maybe only one person knows how to do it. You need to automate all that stuff as fast as you can. As soon as that's automated, it goes without saying that makes your deployment processes faster, it encourages you to deploy more often. There are infinite tools out there. I've put 8 or 9, depending on how you count, on the screen there. If you're not doing this already, if at the minute you are manually copying files around and manually doing anything to get stuff live, start simple, start with a bash script. You don't have to go and figure out how to learn Circle CI. Just start with a simple script that you can write that just does what you're doing right now and start there. And then once you have that, ideally, any solution is acceptable as long as it's a single button click and anybody in the team can do it. Number 8, use containers. It's pretty straightforward. By containers, I'm talking about not the ever given. I'm talking about things like Docker. My advice, use containers everywhere. I think, I'm unopinionated about that. I am opinionated about that. You should be using containers absolutely everywhere, not just in your development environment, but in production. You don't have to be crazy like me and try and run your web browser in a container. That's a bit over the top. I get that I'm a bit of a fanboy, but really everything you're deploying onto a server anywhere should be in a container. The exception, which I will accept, is anything that's sort of platform as a service. If you're using Lambda or Heroku or Google App Engine or whatever, these things where you're not involved in the environment your code's running in at all, fair enough. But if you're involved in, have any sort of infrastructure, any servers these things are going to run on, which I think most people tend to do in a container, you will definitely reap the benefits of it. The next one, tackle technical debt every day. And this is the thing that I think you really need to try, especially if you have a system you're going to be maintaining over a long time. The thing you really want to avoid if you're building a system and you think it might be around for a long time is building technical debt. And we all know what technical debt is. We all know it grows over time, just like normal debt, any other kind of debt. If you don't repay it, it's just going to get out of hand. And one day, there's going to come that dreaded moment where you think, this is just a mess. This is so impossible to use. We need to do a big refactor. That is the goal here, is to avoid that. If anybody in your team ever says, let's have a big refactor month, where we spend 2 months just refactoring code, that's a warning flag. My suggestion how you solve this is try and instill a culture where every time you change something, you improve something. It may only just be you're changing a variable name. It may just be making something slightly more readable. Sometimes you may not change things. But you should never open a bit of code, look at it, and think this is a mess, but I'll just hack my little thing in here and move on with my day. Try and improve it just a little bit each time you touch it, and hopefully you will avoid those big refactor projects. And I think we've done this reasonably well at Opia, because we have, I think our main system that kind of runs the business was, the first commit was when I started nearly 8 years ago, still going strong. So I think it's a good testament of that approach. The last one, take professional responsibility. So it's a bit of a different one. I think Jordan Peterson's a pretty controversial person to quote these days, but I like this quote. Do not agree to things you do not agree with. Now, we're all British, and yeah, we tend to do that. But it goes without saying, really, if you don't agree with something, don't do it. And Hugo, this is someone who has people he has to manage. The obvious example would be something like the Vauxhall emissions scandal from a couple of years ago, and the developers are going, but my boss told me to do it, and everyone else is saying, well, if your boss told you to shoot someone, would you do it? I'm sure most of you aren't dealing with big ethical conundrums like that on a day-to-day basis, but there are more likely other things that you think should be done that aren't getting done. A good example is tests that I talked about earlier. So I interview a lot of people. A number of times someone says, so how much do you do testing? Oh, we don't do it because the CFO says we haven't got budget for it, it's too expensive, or the client doesn't want it. For me, there's a degree of professional
documentation are issue where a client didn't want the internal documentation and I wasn't allowed to do it.
Exactly. It serves many purposes. So for me, it's a degree of professional responsibility there. I don't think it's responsible for me as a professional in my craft to deliver my code without writing tests. And that test is one example. There's many examples like that. I would liken it to, if you had a structural engineer came to your house to build an extension and said, I need to walk this wall down, and it's going to cost 20 grand to do the whole thing, and 10 grand of that is doing tests to make sure your house doesn't fall down. One, you're never going to say, nah, don't need them tests. And two, even if you did, they're not going to say, oh, well, client says they're not going to pay for it, therefore I'm just not going to do it. They're going to say, no, as a matter of professional responsibility, I ain't doing that. And they're going to either walk away from it or you're going to change your mind, one of the two. Hopefully, most of you don't work in teams where you have to walk out over things like this very often. But take responsibility for your own decisions, and make sure you stand by it. Don't sit there and sort of complain, I wish the boss would let me do this. If you think it's really important, make it happen. And that's my 10. Thanks. Any questions? Or comments or disagreements?
On the writing tests now, I think you answered it at the end there. I'm assuming the developers in your team write the automation tests themselves.
Yeah.
What are your views on having sort of dedicated testers to doing that?
So we have an interesting dynamic at Opia because we have two sets of teams. We have our product development teams who work on the platform that has to be maintained long term and is constantly getting changed. Then we have our delivery team who work on the individual campaigns we're building for clients. The big difference is that the individual campaigns we're building for clients, once they're built, they often don't change. And so in that case, actually sometimes the amount of effort you put in depends on how much testing you do. The amount of effort you put in up front, writing automated tests may not pay off. And so we have manual QAs in that process. I definitely think there's room for human QA. I used to disagree with that, but I definitely think that there's a need there. I would say, though, write as much automated tests as you possibly can so that you don't need them and just have them for those catching the edge cases, really.
Yeah, I mean, do you just sort of size that up with the actual development work, just kind of build in?
Yeah, well, our dev teams don't tend to scale up and down a huge amount, so we've got a pretty clear model for ourselves. We know delivery work all goes through QA, human QA, and they're all automated tests, but like I say, the more the end-to-end tests where everything's glued together is more relied on for QA. And the internal stuff, we actually have no QAs there at the minute, but we probably will add one soon because we're scaling up the number of developers. As you have more, inevitably, it's more I've edited something over here and something at the other end of the application is broken, that the good QA people tend to pick up on.
Perfect, cheers.
Yes?
You could only pick one of them, which one would it be?
One of the top 10 tips? Yeah. Don't write the code you don't need to, the first one. I think that's the most important. I think people in my work that aren't in our team hate me because the rest of the business keeps coming up with these ideas of how we can do these things. And I'm like, I know that's going to take 6 months worth of work. I can solve 80% of your problem in a week. And so I think that's where, if you think about our job really is not to write code at the end of the day, it's to solve the business problems. And I think that's where you get the biggest bang for your buck. If you can challenge there, and if you can really understand what the problem we're trying to solve is and focus on that, I think there's a lot to contribute there versus the others. I would say that because my role these days, I don't write as much code as I used to. I spend most of my time doing PowerPoints. Okay, thank you very much.